Hello and welcome to this section. In this section, we look at some of the troubleshooting techniques for Kubernetes. We start with troubleshooting application failures, then move on to troubleshooting control plane failures, and then to worker node failures, and finally, network-related issues. This section is full of hands-on labs where you are given a broken cluster and are... Hello and welcome to this lecture. Throughout this course, we've actually worked on a number of troubleshooting exercises with respect to the topic we were going through at that point in time. So a lot of troubleshooting is already covered. We will go through an overview of troubleshooting techniques and procedures and work on some more practice tests in this section. We start with application failures. Let's take a look at a two-tier application that has a web and a database server. The database pod hosts a database application and serves the web servers through a database service. The web server is hosted on a web pod and serves users through the web service. It's good to write down or draw a map or chart of how your application is configured before you start. Depending on how much you know about the failure, you may choose to start from either end of this map. But remember to check every object and link in this map until you find the root cause of the issue. Say in our case, users report some issue with accessing the application. First, we start with the application front end. Use standard ways of testing if your application is accessible. If it's a web application, check if the web server is accessible on the IP of the node port using curl. Next, check the service. Has it discovered endpoints for the web pod? In this case, it did. But if it did not, then you might want to check the service to pod discovery. Compare the selectors configured on the service to the ones on the pod. Make sure that they match. Next, check the pod itself and make sure it is in a running state. The status of the pod as well as the number of restarts can give you an idea of whether the application on the pod is running or is getting restarted. Check the events related to the pod using the describe command. Check the logs of the application using the logs command. If the pod is restarting due to a failure, then the logs in the current version of the pod that's running the current version of the container may not reflect why it failed the last time. So you either have to watch these logs using the -F option and wait for the application to fail again, or use the previous option to view the logs of a previous pod. Next, check the status of the DB service as before. And finally, check the DB pod itself. Check the logs of the DB pod and look for any errors in the database. There are some more tips documented in the Kubernetes documentation page for troubleshooting applications. This will help in upcoming practice tests as well as in the exam. Okay, so let's go through this practice test on troubleshooting application failure. In this lecture, we will see different ways of troubleshooting control plane failures. We start by checking the status of the nodes in the cluster. See if they are all healthy. Then check the status of the pods running on the cluster. If we had control plane components deployed as pods, in case of a cluster deployed with the kubeadm tool, then we can check to make sure that the pods in the kube system namespace are running. Or else, if the control plane components are deployed as services, as in our case, then check the status of the services such as the kube API server, the controller manager, and scheduler on the master nodes, and the kubelet and the kube proxy service on the worker nodes. Next, check the logs of the control plane components. Again, in case of kubeadm, use the kubecontrol logs command to view the logs of pods hosting the control plane components. In case of services configured natively on the master nodes, view the service logs using the host's logging solution. In our case, we could use the journal control utility to view the kube API server's logs. This should be a good start. For more tips, refer to the Kubernetes documentation page for troubleshooting clusters. This will help in the upcoming practice test as well as in the exam. In this lecture, we will see different ways of troubleshooting worker node failures. Again, we start by checking the status of the nodes in the cluster. Are they reported as ready or not ready? If they are reported as not ready, check details about the nodes using the kubectl describe node command. Each node has a set of conditions that can point us in a direction as to why a node might have failed. Depending on the status, they are either set to true or false or unknown. When the node is out of disk space, the out of disk flag is set to true. When a node is out of memory, the memory pressure flag is set to true. When the disk capacity is low, the disk pressure flag is set to true. Similarly, when there are too many processes, the PID pressure flag is set to true. And finally, if the node as a whole is healthy, the ready flag is set to true. When a worker node stops communicating with the master, maybe due to a crash, these statuses are set to unknown. This can indicate a possible loss of a node. Check the last heartbeat time field to find out the time when the node might have crashed. In such cases, proceed to checking the status of the node itself, if the node is online at all or is crashed. If it's crashed, bring it back up. Check for possible CPU, memory, and disk space on the nodes. Check the status of the kubelet. Check the kubelet logs for possible issues. Check the kubelet certificates. Ensure they're not expired and they're part of the right group, and that the certificates are issued by the right CA. Well, that's it for this lecture. Head over to the practice test and practice fixing broken clusters. Okay, so in this lab, we're going to practice troubleshooting worker node failures. So we'll wait for the lab environment to be ready and we'll get started. While we wait, I'm going to set the alias for kubectl. Okay, so the first question is to fix the broken cluster. So let's run a kubectl get nodes. And we see that indeed there is something broken. So node 01 is in a not ready state. So let's see why that is. Let's do a describe node 01. And here we see a set of events. So all of these seem to be normal. So that's starting the kubelet. All of these are good statuses. And the node itself is ready. There's something missing. So let's go to that node, SSH to node 01, and we'll check the status. So the first thing that we want to check on a worker node is the kubelet, because as we know, the kubelet is the controller of a node, and the kubelet is what helps in communication between a worker node and the master or the control plane node. So let's do a check the service of the kubelet. So service kubelet status, and we see that it's loaded, but it's in an inactive state. So we don't know why it's in an inactive state. So we're going to just try and start it. So let's do a service kubelet start, and let's check the status again. We see that it's now in an active and running state. Let's go back to the control plane and let's do a kubectl get nodes. Okay, and we see that it's both are in a ready state. So I think that should fix that question. Okay, let's go to the next one. Okay, so the cluster is broken again. Investigate and fix the issue. So let's check the status again. We see that it's again in a not ready state. So let's check the status of the node 01, and go to full screen. We see that all of these events are normal, so that's okay. And there's nothing here either. So let's go to the node and check the status of the kubelet again, service kubelet status. And we see that it's in an activating state, and it looks like there's an exit code and it's exited. The status is 255. So that means it's not, there is something wrong and the process is not able to start. So even if we do a service kubelet start, it's not actually going to start the service because there seems to be something wrong. So let's check the status of the service again, and it's in an activating state. So to look at the logs of a service, do a journal -u kubelet, and let's check the status. So these are the logs, and let's look for the latest, the most recent logs. Okay, so we're here. Let's go up. So all of these seem to be an error from a previous error. All of these seem to be an error message, and here you can see that there's an error that says unable to load client CA file /etc Kubernetes PKI wrong CA file. There seems to be a wrong file, so let's try and find that out. So the kubelet configuration files are one in the etc Kubernetes kubelet.conf. So that's one file. But this is basically the kubeconfig file used by the kubelet. So here you have the certificate, the context, and everything that the kubelet uses to connect to the kube API server. So this is not the place where there's an issue. It's basically the kubelet service itself, right? So the kubelet service picks the options from a file located at var lib kubelet. So this is something to remember. And here you have a file called config.yaml. So var lib kubelet config.yaml. And within this file, there are some properties that are passed through to the kubelet. And here you can see there's this wrong CA file right here, and that's the client CA file. So it should be the correct file. So let's find what the correct file is. And there's this ca.cert file. So that's what it should be, ca.cert, instead of the wrong CA file. So let's edit that. And input the correct ca.cert. Save that. And now we're going to restart the kubelet service. And let's just check the status of the service now. And we see that it's in an active running state. Let's go back. Let's go back to the control plane node. And let's check the status of the nodes. And we see that they're in a ready state. Okay, so let's go to the next one. Okay, so now the cluster is broken again. So let's check. And we see that, yes, it is indeed broken, and node 01 is not ready. So let's go to node 01 and let's check the status of the kubelet. And we see that it's active and it's in a running state. Okay, so let's check the logs. -u kubelet. And let's go all the way to the end. And let's work our way backwards. Okay, and let's see if there's something useful here. So here you can see unable to register node, and you can see the control plane and dial TCP 10.54.132 6553 connection refused. So this seems to be the error that's causing the remaining errors. And if you look at it, it says connection refused to this, and this is basically for the control plane that we have. And it looks like this port number is incorrect because we know that the control plane port number is 6443 and not 6553. So that could be the error. So let's take a look at the kubeconfig file used by the kubelet. So we saw that the kubeconfig file used by the kubelet is etc kubernetes and kubelet.conf. So let's take a look at the contents of the file. So here, if you look at this, you see that right here, the control plane port number is incorrect. So let's get that corrected. We'll set it to 6443. And we're going to do a service kubelet restart. And service kubelet status. You see that it's now in an active state. Let's check the logs as well. And we no longer see those errors, and it seems to be good. Let's go back and let's check the status of the nodes, and we see that it's now ready. Let's check our work. Okay, so that's the end of this lab. So when it comes to troubleshooting worker nodes, always first check the status from here, from the control plane, and check whatever you can find from here. And then go to each of the worker node that has the issue and start with checking the kubelet service. If the kubelet service is good, check the logs of the kubelet service and continue your way from there. Well, that's all for this lab. Thank you. Okay, so in this video, we're going to work on troubleshooting control plane failure. So the first question is, the cluster is broken. We tried deploying an application, but it's not working. Troubleshoot and fix the issue. So before we begin, a quick tip. If you don't have the alias set already on your prompt, so you could do a alias k equals kubectl. And also, if you don't have auto completion, then one thing you could do is you could go to the Kubernetes documentation pages, search for kubectl cheat sheet, and then the first thing that comes here is the kubectl completion bash. So let's copy and let's run that, and this basically gives you auto completion. So you do a kubectl get, and then it automatically gives you the options. The other thing is, so if you're setting an alias, you should do this as well to get the alias for the short form for kubectl. So I'm going to set this as well. That way I can just do kubectl get, and then auto completion for the short form. Okay, so we're going to look at the status of the cluster. So let's do a kubectl get nodes, and we see that the node seems to be in a ready state. So that's good. It says there are deployments. So let's take a look at the deployments. And we see that there is an app deployed, but it's not ready. So there is one container or one pod in the deployment, but that pod is not ready. So let's take a look at it. Let's do a describe. So describe deployment app, and we see that there's one desired, 0 available. So there's one unavailable, and there isn't anything here that's really helpful. So here it says scaled up replica set to 1. So let's take a look at the replica set. Get rs. We have one replica set. Let's take a look at that. Describe replica set app, and we see that the desired is 1, but it's still waiting. And here you have the events, and it says creating pod. So let's take a look at the pod, and we see that there is a pod created, but it's in a pending state. Let's take a closer look at that pod, and we see the events have not started yet, but everything else seems okay, but it's in a pending state. So when a pod is in a pending state, it's most likely that indicates that it has not been assigned a node. So if you look at the node here, it's set to none. That means the pod has not been assigned to a node. And the job of assigning a pod to a node is scheduler's job, right? So we have to look at the status of the scheduler. So let's do and we know that scheduler runs as a pod in the kube system namespace. And here you have the scheduler, and it has control plane at the end. So that means it's a static pod, and its status is crash loop back off. So let's take a look at the pod in more detail in the kube system namespace, and we're looking at the kube scheduler. Okay, so we see at the bottom here that seems to be restarting quite often, and then it says failed to start container kube scheduler, error response from daemon, OCI runtime create failed, starting container process kube scheduler, executable file not found. So it says this executable is not found. Obviously, it looks like it's not right. So let's take a look at the options or the command that are used to run this pod. So here we can see that there is an incorrect command that's run, and that's the reason. So we know that the kube scheduler is a static pod. So the file is in etc Kubernetes manifests, and we have the kubescheduler.yaml file here. So this is the manifest file for kubescheduler, and within that there's a wrong command. So let's go and edit that file, and then we remove the extra characters, and we're going to save that, and we'll see if we have, let's see the status of the pod, and it's in a creating container config error state. Yep, it's now in a running state, and we'll just watch until it's ready. So let's give it a few seconds. Still not ready. Let's take a look at the logs. Okay. Okay, so it's finally in ready state. And let's take a look at the pods. And we have the pod is now in a ready state. Let's take a look at the deployment. And we have 1 of 1 ready. Okay. Okay, so that's good. Let's go to the next one. Now it says scale the deployment app to 2 pods. Let's do a kubectl. So let's get the deploy. And we have app with 1 pod. Let's scale it up. Kubectl scale deployment app, and replicas is 2. That's 2 pods. Okay. Even though the deployment was scaled to 2, the number of pods does not seem to increase. Investigate and fix the issue. So let's check the status of pods. And we see that it's still just 1, but we have the deployment here. It says 1 of 2 ready. So let's take a look at the deployment. Kubectl describe deploy app, and we see the image set. We see scaled up replica set to 1, but we don't see the deployment scaling up the replica set to 2. However, here we see the number of replicas to be 2. 2 is the desired state, and only 1 is available. So the job of updating a deployment, the job of updating a replica set or scaling up a replica set is the controller managers. So it's the deployment controller, and all the controllers that, as we know, the deployment controller, the replica set controller, they're all controlled by the controller manager. So let's take a look at the status of the controller manager. So we're going to do a kube system, and we see that the kube controller manager is in a crash loop backup state. So let's take a look at the kube controller manager. So within the new system, we're going to describe this particular pod, and we see that it says back off restarting failed container. We don't see anything useful here in the events. Let's take a look at it. So here it says crash loop back off terminated error. The exit code is 1, and the command seems to be correct. There isn't anything bad there. So let's take a look at the logs. So let's do a kubectl logs. This one in the kube system namespace. Okay, so here it says this particular file, there's no such file or directory. So this file is not found. Let's check if that file exists. Of course, that file does not exist because there seems to be something wrong with it. So let's check where this file is specified in the kube controller manager. So we know that the kube controller manager is also a static pod, so that means it must be in the /etc Kubernetes manifest directory, and then we have controller manager there. So let's see. Let's just grep for xxx because that's what we saw, and here we have it specified. So the kubeconfig file is configured to this location, but let's see where the actual kubeconfig file is. Right. So the actual kubeconfig file for the controller manager is at etc kubernetes controllermanager.conf. Let's just verify that the contents of that file. Let's do controller manager, and we see that this is indeed a kubeconfig file. Okay, so that's the problem. So we're going to edit the controller manager manifest file to fix that issue. So we're going to remove this xxxx that is not required. We're going to save that, and we'll check the pod system. It's in a pending state, so we're going to watch that, and we'll give it some time for the kube controller manager to be ready. Okay, so it's now in a running state and it's also ready. So let's take a look at the pods, and we see that there are now 2 pods indeed. Let's take a look at the deployments, and we see that there are 2 deployments. Okay, let's check the status. Okay, so we're breaking something now. Okay, so something is wrong with scaling again. We just tried scaling the deployment to 3 replicas, but it's not happening. So let's take a look at that. Let's do a get pods. It's only 2. Let's do a get deployment, and it's 2 of 3. So it looks like it's gone to 3. So let's check. Let's look at the deployment, and we see that here we have scaled up the replica set to 1, then 2, which we did earlier, but it has not been scaled up to 3. So in the previous one, we've learned that if the this scaling up isn't happening, if the changes that we've applied on the deployment isn't going into effect, then the culprit is usually the controller manager, because it's the controller manager that is responsible for this. So let's take a look at the controller manager again. Okay, so we're going to look at the logs of this pod controller manager. So we're going to do a kubectl logs. This is the control plane controller manager in the kube system namespace. And we see that it says unable to load client CA file. So the etc Kubernetes PKI CA is not available. So let's try and find this file locally. And we see that we do have this file locally. So yes, this file seems to be here, but it says it's not able to load it. There's no such file or directory within the kube controller manager. So we know that the way that the kube controller manager or any other control plane component is set up is that the certificate files are on the control plane on the host, and then we use volumes to mount these directories within the same directory within the controller manager, right? So that's set up in the manifest file. So let's take a look at the manifest file. And we're going to look at kube controller manager. And we see that all of these that are configured here, so etc Kubernetes, etc Kubernetes PKI, these are all in fact on the host, but they are mapped as a volume through to these containers. And the way that's done is through volume mounts. So we look at volume mounts here, and we can see there are multiple volume mounts. So you have etc SSL certs,
the CA certs, but what we want is the Kubernetes PKI volume. This is what we are concerned about because this is what it claims that is not available. So here the mounting looks good, but the volume that is mounted is called K8 certs. So let's take a look at the K8 certs volume. So these are the volumes that are configured here. And here we have the K8 certs volume. And this is the section for that. And within this, we have the path, which is given at the top. And here you can see that there's an incorrect path given. So it says wrong PKI directory. So we're going to have to get rid of that and add the right PKI directory, which is just PKI. And just going to save that. Let's take a look at the pod status now. Okay, it seems to be in a running state. And so let's watch it and wait until it is back up and running. Okay, so it's now in a running state. Let's take a look at the status of pods. And we see that we have 3 pods indeed. And if we take a look at the status of the deployment, we see that we have 3 out of 3 ready. Okay, so that's the end of this lab.